So some students were confused with using their sample space if they, for example, make a probability tree, or using the addition or multiplication rules for compound probability. So I just wanted to clear some things up. Okay, just as a reminder, compound probability is when you have more than one event going on at the same time. An event is something that you want to happen. Remember, if it is, you want, let's say, the probability of picking a king and picking a jack. Okay, since that's an and problem, we're going to multiply. If I wanted the probability of a king or a jack, that's a addition problem, I'm going to add. Okay, and when we say multiply or add, what we're doing is we're finding the probability of a king and then times the probability of the jack by itself. Same way with the other one. So if I was adding, I would do the probability of the king by itself plus the probability of the jack by itself. And that is, I think, where some people were getting mixed up. So let me show you an example. Okay, so here's an example. Mrs. Pierce went out to lunch. Instead of picking her lunch herself, the waitress randomly chooses one sandwich, one side item, and one drink randomly from the following options. So for sandwiches, the options are tuna, ham, and turkey. For the side items, we've got salad, fries, and pasta salad. And for the drink, there is iced tea and water. So the best choice usually is to make a tree diagram or some other sort of picture to help you organize all of the combinations. All right, so doing this by hand, let me make this a little bit smaller. Okay, I've got tuna, ham, and turkey. I'll make turkey to you. I'm going to try to spread this out as best as possible because that's the key. Making sure you're neat, making sure you spread it out. Then we've got salad, fries, pasta salad. Salad, fries, pasta salad. Notice how I am kind of lining these up in a row so that it's just neater. All right, let me get rid of that line, maybe. Maybe not. Okay. And then again, if there was tuna, I could have salad, fries, pasta salad. And then last, we would have the option of iced tea, water. Iced tea, water, iced tea, water. And I'm just going to keep going. Again, trying to be neat so that I don't miss anything. And that is really hard to do. Okay, so if I count them, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 combinations. And I think I told you guys this before, but you could have said, well, there was 3 choices for the sandwich, 3 for the drink, and 2 for the water. And if we multiply them, we'll get 18. All right, so if we list all of our possibilities, I'm actually going to pause this and then make a list so that I don't waste the time making the list for you guys. Okay, so here are all the combinations. So I made a tree diagram to help me organize my list. I made a list, and now let's say we want, what is the probability that we get tuna fish and water? Okay, all that I'm worried about is tuna fish and water. So I'm going to go through and circle the tuna fish and water. So tuna fish and water, tuna fish and water, tuna fish and water. There is 3 out of 18 times that I got tuna fish and water. That is actually 1/6. Or maybe we want the probability that we get, let's say, ham, fries, and iced tea. And I noticed above that instead of tuna, well, yeah. All right, so ham, fries, and iced tea. Let's see, ham, fries, iced tea. there is only 1, so that would be a 1 out of 18 chance. So that is how I would do use my combinations, my sample space, this would be called, for finding the probability. So I'm going to go to the next screen and we're going to do the same problems. Probability that we have tuna or turkey, whichever that might be, and water, and the probability that we've got ham, fries, and iced tea. Okay, so here were the two probabilities we did before. Now the first one says, what's the probability that we get tuna, or maybe it was turkey, sorry, and water? Okay, it's an and problem. And so if it's an and problem, basically I'm going to find the probability of tuna times the probability of water. So I'm going to go back up here. Just look at these three. The probability for the sandwiches being tuna or turkey would be the same, would be 1/3. So that would be 1/3. The probability of the water, well, down here there was only 2 choices, so it would be a half, so that'd be times 1/2, and when I multiply those two fractions we get 1/6. And that's what we got when we simplified using the tree diagram. And then in the other one, probability that we got ham, fries, and iced tea. Now notice it doesn't say and in the middle, but that's kind of assumed because we want all 3 things to happen. So I need the probability of ham times the probability of just fries times the probability of iced tea. Well, the probability of ham is 1/3 because out of the sandwiches, 1 out of 3 is ham. The probability of fries is 1/3 also because out of the sides there was 3 things, so 1 out of 3. And the probability of iced tea is 1/2 because there's only 2 choices for drinks. And then if I multiply those 3 together, it would be 1/18. So some of you were confused and trying to use the combination rules, and you were getting mixed up. So either multiply, but when you multiply, do each thing separately, or use your sample space and just count how many there are. Okay, I hope that helps. Let me know if you need more help.